Okay guys, welcome back to another video. And in this video, we're going to be talking about the sign the acceleration due to gravity is supposed to take when we're using equations of motion. Now, it all depends on whether you choose to introduce a coordinate system or not. Now, in this video, I'm going to explain how we can use the acceleration due to gravity in equations without introducing a coordinate system, producing the right results, the right answers. Now, let me first rub this off so that you get to understand. Okay, so this is the topic of the video, or the title of the video, if you will. Now, like I said, I'm going to be working with the equations of motion, but not introducing a coordinate system into the entire structure. So I'm going to show you how you can successfully get the answers or the correct results using the equations of motion without utilizing a coordinate system. Now, the first thing, or the most important thing to note is this. The force of gravity always acts towards the surface of the earth. Now, you may say towards the center of the earth. That's okay, that's fine. But it always acts, say, in one direction, if you will. That is towards the center of the earth or towards the surface of the earth. Now, this is the surface of the earth. Now, the acceleration due to gravity is the acceleration a constituent particle, a mass, a body would experience under the influence of the force of gravity. Now, let's just consider a mass, say, let's call it M. And we supposedly throw this mass up into the sky. Now, if we do so, as our mass moves, or as our ball, whatever we choose to call it, as it moves going upwards, it begins to oppose gravity. Now, it is important to note that if we neglect air resistance, say there is no air resistance, which is usually the case, like when you're asked about the equations of motion in your exams, it's usually the case that they assume that there is no air resistance. So we throw a mass up, M, up into the sky. Now, the only force that is going to be acting on it as it's going up is the force of gravity. Now we're close to the surface of the earth, so our force of gravity isn't varying. It's approximately constant, as is usually the case when you're taught. So we throw our object up into the sky. Now, like I said, I want to show you how you can use the acceleration due to gravity without introducing a coordinate system. So I'm going to be real quick. I want this video to be very short. Now, what you do is, there are two possible scenarios here. Either, let me use a different color. Either we get an acceleration due to gravity that's downwards, or we get an acceleration due to gravity that's upwards. What am I saying? Sign-wise, we get an acceleration due to gravity that seems as if the object is going down, or we get an acceleration due to gravity that seems as if the object is going up. Now, I know it seems a bit confusing. Let me explain further. Like I said, let's continue to work with our example here of the mass M. Now we've thrown our body M up into the sky. Let's utilize this equation of motion. V is equals to U plus AT. That is the velocity is equals to the final velocity is equal to the initial velocity plus the acceleration experienced by our mass times the time taken, or the time it experiences this acceleration, the time it takes experiencing this acceleration. Now, when we've thrown our body up, bear this in mind, please bear this in mind. This is the tool, this is the trick. When a body is thrown upwards, please drill this into your head if you're not comfortable with using coordinate systems. When a body is thrown upwards, say it is thrown upwards with a velocity of 50 meters per second, it is common sense that the velocity begins to decrease. Now, because the velocity begins to decrease, it means something is eating up the velocity. Now, we're not going into the big details of what's really happening, like on a micro scale, but the velocity basically begins to decrease. Now, because of that, without introducing a coordinate system, when you're working with the equations of motion, when you're supposed to substitute the acceleration of gravity here, use a negative sign, like so. V is equal to U, let me use a different color here, minus gt. Now, g being the acceleration due to gravity, of course, you'll be given, maybe it might be 9.81. So in this case, you would have something like V is equals to U minus 9.81 t. So whenever a body is thrown upwards, because the velocity is decreasing, we are supposed to be subtracting from it, because eventually it might reach zero. So we are supposed to be subtracting from it. This is the trick you're supposed to use if you do not want to introduce a coordinate system. Now you may ask, okay, if we introduce a negative sign for the acceleration due to gravity in this case, what about V? What about U? What signs do they get? Or if we're using an equation like V squared is equals to U squared plus 2AS, what sign are we supposed to get for S? The moment you begin to think that way, know for a certainty that you're now thinking in terms of coordinate systems. Do not worry about all that. Do not worry about all that. Just work with a negative sign on the G. All the other results are supposed to be positive. So you're supposed to get a positive value for V if your working is correct. You're supposed to get a positive value for V, whatever it may be, even S. You're supposed to get a positive value for S, given that you did not introduce a coordinate system. Meaning, whatever velocity you get when you're going up has to be positive. If you're working with the displacement, it has to be positive. Everything has to be positive. Now you may ask, what if the ball is going downwards? What if the mass is going downwards? We now have this case. What happens? In this case, we use, let me use a different color again. We use a positive sign for the acceleration due to gravity. So meaning, when we come here, we put a plus so that we get such an equation. And in this scenario, if we break it further, or if we go down with it further, in the former scenario, we would put a negative. Now in this case, we will put a positive, just like so, as it is. In the former scenario, where the ball is going upwards, we would use a negative here. But in this case, where the ball is going downwards, we use a positive. Again, you might ask, what then happens to the values of, sorry, let me put a G here. What then happens to the values of S, to the values of V, to the values of U, to the values of V? Do they alter in sign because I've introduced a different sign for the acceleration due to gravity? No, the values you'll always be getting will be positive. As long as we do not introduce any coordinate system, the values you get for the final velocity, the values you work with for the initial velocity, the values you get for the displacement will always be positive. The only thing we have to be worried about is the acceleration due to gravity. So if you look at this, in a sense, this is a better way of working with physics. Or this is a better way of working with the equations of motion in physics, so that you do not confuse or end up mixing the signs. Because the moment you introduce a coordinate system, things go haywire. If you are not careful, you might mix up the signs and get the wrong values. So if you're a person who's not comfortable with using coordinate systems, better stick to this method. Again, I'll repeat. Okay, now let me answer this question. The sign of the acceleration due to gravity, is it positive or negative? If you do not introduce a coordinate system and you work this way, it's negative if you're working with an object that has been thrown up. It's positive if you're working with an object that's falling or that's going down. Always keep this in mind, and I hope this video was very helpful, guys. So that's it, ladies and gentlemen. Thank you very much for your time. If you want more videos like this, please comment. If you found this video helpful, comment, subscribe, and like. It grows the channel, it grows the audience. The video goes to a lot of people. Thank you very much. Now, if you find any negative things or discrepancies with the way I'm presenting this content, please let me know in the comment section. Your criticism is very helpful. It makes the channel grow. Thank you very much. Have a good time. Stay motivated.